Hi Math 2 students, it's Mrs. Robinson. I'm back to work the practice benchmark chapter 5 for those of you that want a little help with it. Let's go ahead and start with the first problem. Let me see if this will let me draw. All right, the first problem asks, what's the measure of one interior angle of a regular 24gon? So when you're working this problem, you want to remember the formula. N minus 2 times 180 gives you the sum of the interior angles of a polygon. So if I have a 24gon, my number is going to be 24. 24 minus 2 times 180 will give me the sum of the interior angles of a regular 24gon. So I'm going to go 22 times 180. Go ahead and calculate that out. You can use a calculator or just write it out long ways. So I'm going to get 3960. All right, that's the sum, but I want the measure of one interior angle. Since it's regular, I'm going to divide that by 24. When I do that, my solution is 165. So that is the measure, degrees it would be, the measure of one interior angle of a regular 24gon. So this is the formula that you would use when you're working just the sum of an interior angle. And if you wanted to find one interior angle of a regular, remember it has to be regular for this to work. The formula would be n minus 2 times 180 divided by whatever that number is, 24. And it only works for a regular, meaning all the angles are the same measure. All right, so make sure you know that. All right, let's go to the second one. Find the value of x and y. Now, if you look at this polygon, you can tell it's not regular. Look, there's different measures for each angle. I can still find the sum of the interior angles of any polygon. I just can't find one using this method because it's not regular. So let's go ahead and go n minus 2 times 180. That will give me the sum. And when I do that, I see I have 1, 2, 3, 4, 5 angles, or 1, 2, 3, 4, 5 sides. So I'm going to go 5 minus 2 times 180 here. All right, when I calculate 5 minus 2 times 180, that's 3 times 180, and that's going to give me 540. Now to figure out this angle, I can't divide by 5 because this isn't regular. I have to subtract off all these angles to figure out this angle. So I'm just going to go 540, and then I'll subtract off 95, 125, 105, 116. And when I do all that work, I'm going to come out with 99. So angle x will be 99. And then I can find angle y because this is a line and these will be supplementary. I'm just going to go 180 minus 99. And that should give me 81. So angle y will be 81, and that will be in degrees. All right, okay, let's go on to number 3. Number 3 asks to find let's go ahead and draw. Number 3 asks to find the sum of the measures of 3 exterior angles of a quadrilateral. It doesn't say find. It just says the sum of the measures of 3 exterior angles of a quadrilateral is 275. What is the measure of the fourth? So we have a little formula that we know. The sum of the exterior angles of any polygon is 360. We know that. Now, this doesn't say it's a regular quadrilateral. It just says the sum of the measures of the exterior angles of a quadrilateral is 275. So I have 3 exterior angles. If it's a quadrilateral, I should have 4. I know the sum of exterior angles of any polygon is 360. That's exterior. It's not regular, but I know 3 of the angles sum up to be 275. I have 1 angle left, so I'm just going to subtract 275 from 360. Just do the math on this and you'll get 85. So what is the measure of the fourth angle? 85 degrees, because the sum of the measures of any polygon of their exterior angles will be 360. So make sure you know that. All right, let's go down to number 4. And hold on. All right, number 4, it asks for the measure of the numbered angles. And we know in a parallelogram that opposite angles are congruent. So let's go ahead and do measure of angle 1. Measure of angle 1 is going to be 113. We've got that down. We also know, since this is a parallelogram, these lines are parallel. And if you extend the lines out, this would be a transversal. So alternate interiors will be congruent. So if this is 22, this will be, measure of angle 3 will also be 22 degrees. All right. If these are parallel and this is a transversal, let's go ahead and do these being parallel. That wasn't very good, but these are parallel. And this is the transversal right here. Let's see if I can draw that very good. And then these would be alternate interior angles. So measure of angle 2 and 45. Measure of angle 2 would be 45 degrees. All right, so you've got all your angles just knowing that this is a parallelogram. These are parallel and these are parallel. Helps us find everything we need to know. All right, on to number 5. This is a parallelogram. I need to find angle 1. I know angle 1 and this angle will be congruent because opposite angles are congruent in a parallelogram. Now I know same side angles are supplementary. I have 2 parallel lines and a transversal. Same side interiors are supplementary. So this plus this should be 180, and that's what I'm going to set up here. 8s plus 5 plus 3s plus 10 equals 180. Now, a big mistake that I see on this one a lot is students will set these equal to each other and try to solve for s. These are not congruent. Same side interiors are supplementary. So you need to add them together and set them equal to 180. Then we'll solve for s. 8 s's plus 3 s's are 11 s's. So combining like terms, 5 and 10 is 15. That equals 180. And then just do your solving. Minus 15, minus 15. That is ugly, but it's working. 11s equals 180 minus 15. And then divide by 11. And s is going to be equal to 15. All right, so I figured out s. I haven't solved my problem. That's not the solution. I have to plug it in here to figure out this angle, and then I'll know angle 1. So a couple steps here. 3s is 15, so 3 times 15 plus 10. And then just do the math on this. 3 times 15 is 45 plus 10 is 55. 55 is the measure of this angle, so the measure of angle 1 equals 55 degrees. All right, let's go ahead and go on to the next one. Okay, the best thing to do on these is make sure you label things. If EF equals 3x minus 3, label it so you can see what you're looking at. DG is 2x plus 2. We want to find the value of x and then find the length of EF and DG. They told us this is a parallelogram. Since you know it's a parallelogram, you know properties, you know opposite sides are congruent. So you then go ahead and set them equal to each other and solve for x. And that's all you have to do here. I set the 2 sides equal to each other, do the basic math on the algebra here. Subtract 2x from both sides. You're going to get 2 equals x minus 3, and then add 3 to both sides. There's a little delay in my writing there. And you're going to get x equals to 5. I've solved for x. Now finish the problem, plug it in here. 3 times 5 is going to be 15, and 15 minus 3 is 12. This is 12. I don't have to plug it in here. I should get the same answer because these are congruent, 12 and 12. So what are the lengths of EF and DG? EF equals DG, which equals 12. All right, on to the next one. Let's erase this off. In the figure, the horizontal lines are parallel, and we are also told GH equals HI equals IJ. So these are all congruent. Then it tells us to find DE, this length. So we have a little postulate or theorem, and we know if we have 3 or more parallel lines cut by transversal, and it cuts one transversal in congruent segments, it cuts all transversals into congruent segments. So if these are congruent, then that means this segment and this segment and this segment are congruent, not to these, but to each other. This would be congruent to this and to this. And in this long segment, you would have this segment congruent to this segment, congruent to this segment, okay? Not to each other, just to the segment pieces. All right, so knowing that and the information they've given us, it told us to find DE. Well, they give us one of the segments, it's 5. So I know this is 5 and this is also 5. So the full length here will be 5 plus 5 plus 5, or 15. 15 is DE. So this is just a test to see if you know that theorem. All right. Okay, number 8 asks you to find the values for x and y that would make this a parallelogram. Well, in order for this to be a parallelogram with what I have here, the easiest thing would be to have both sets of opposite sides congruent. So that's what we're going to do here. Now, looking at what I want to set up first, this has a y in it and this has an x in it. So if I set these equal to each other, I'm not going to be able to solve for anything because I don't have the same variable. These both have x's in them, so I'm going to set those equal to each other, and I'm going to do this. 3x plus 3, that's a 3, equals 4x minus 9. Solving for x, do the algebra, subtract 3x from both sides, and I'll get 3 equals 4x minus 3x is x minus 9, and then add 9 to this side. That's a 9. Sorry, this thing is hard to control. And I'm going to get x equals 9 plus 3 is 12. That's 12. All right, so I've solved for x. That's my first thing. Now I've got to figure out y. Well, here's what I do know. I know x is 12, so I can come over here and plug in 12. 2 times 12 is 24. Plus 1 is 25. Now I know this length here is 25. Now the reason I do that is because now I can set these equal to each other and I only have one variable to solve for. Since it's a parallelogram, or I want it to be a parallelogram, these sides need to be equal. So now that I've figured out my x, I plug it in, now I can go get my y. 2y minus 3 equals 25. You want these sides to be equal to each other and solve for y over here. Plus 3 to both sides, that's a 3. Ew. And then 2y, yeah, this thing is hard. 2y equals 25 plus 3, which is 28. And then divide by 2, and you're going to get y is 14. And you're finished. X is 12, y is 14. All right, on to number 9. Based on the diagram, or the information in the diagram, can you prove that this figure is a parallelogram? Explain. So we have several things that we can do to prove that a figure is a parallelogram. One is both sets of opposite sides are congruent. So this is congruent and these are congruent. That's what we just used here, but we don't have that. Both sets of opposite sides are parallel. These are parallel or these are parallel. That's another thing. Now there are several other things about diagonals, and the thing about what we have here is we have one set of opposite sides parallel, one set of opposite sides congruent. It's not quite enough information. I either need this to be marked like this, so I know both sets of opposite sides are congruent, or I need this to be marked like this, so I know both sets of opposite sides are parallel. Instead, I have one set of opposite sides congruent, one set parallel. So I'm going to put on this no, based on what I just have here, no, and this is why. The same pair, that says same if you're wondering, oh, sorry, of opposite sides needs to be both congruent and parallel. Okay, so we have another theorem, and this is why I chose this. They give us parallel and congruence. If I had the same pair of opposite sides that were marked congruent and parallel, then I would have a parallelogram. Or you could have said, no, because I need to have both sets of opposite sides congruent. Or no, because I need to have both sets of opposite sides parallel. Or I need to have the same set be both parallel and congruent, not different sets. Okay, so make sure you know the rules that make something a parallelogram. All right, and then give me a reason. Okay, I just looked up the page to make sure you guys know what page, all of the ways that you can prove a quadrilateral is a parallelogram. In your student book, it's on page 285. Yeah. And make sure you look up all those ways. And the theorem that I was referring to is theorem 49. That's the one that says one set of opposite sides needs to be both congruent and parallel. All right, let's go to number 10. Can you prove the quadrilateral is a parallelogram based on the given information? Explain. First of all, I need to scroll up. Hold on. Okay, and here's our quadrilateral. And we're given AE, let's mark it, is congruent to EC, and then BE, here's BE, that is congruent to ED. So I have diagonals that bisect each other. Now on that page I just referenced, if you look, theorem 48 is the one that talks about this. And that theorem says this. To prove that a quadrilateral is a parallelogram, you can simply prove that diagonals bisect each other. If diagonals bisect each other, the quadrilateral is a parallelogram. So yes, because of theorem 48, diagonals bisect each other. Yeah. I'm so sorry for this. It's not allowing me to write. Okay, we get the gist. That's taking too long. Okay, let's go ahead to number 11. Classify the figures in as many ways as possible. Now, the basic figure here is a quadrilateral. It has 4 sides. Okay, and before that, you could even say it's a polygon. Polygon. I won't mark you wrong if you don't start here. But you could say polygon on this one. Polygon because it has multiple sides and it's actually all the sides are touching. There's not something that's left open, so it is a polygon. All right, convex, concave, polygon, just a polygon. All right, it is a quadrilateral. It has 4 sides. But what I'm most looking for here is these two. I have one set of opposite sides congruent and another set of opposite sides congruent. So the first thing I should see here is this has to be a parallelogram. Okay, I'm just going to stop there because the writing on this is super hard. Parallelogram, all right? And then the next thing, more specifically, since I have both sets of opposite sides congruent and I have 4 right angles, I also have a rectangle. Okay, so I'd like to see these two most specifically. All right, going down to number 12. Let me go ahead and scroll down. It takes me. All right, we got to know some properties of a rhombus here in order to answer this one. Let's go ahead and look. In a rhombus, it's still a parallelogram. I see all 4 sides are congruent. So if I have this side, and this being the transversal, alternate interior angles are congruent. So if that's 54, this is 54. All right. Now, since I have these markings here, this is an isosceles triangle. So the base angles are congruent. So this has to be 54. Now, if this is 54 and this is my parallel line and this is my transversal, this is going to be 54. So angle 3 is 54. All right, now this is 54 and this is 54. I can figure this out because I have a triangle. 180 minus 54 plus 54 is 108 minus 108. And that gives me 72 degrees. So angle 4 is going to be 72 degrees. And opposite angles in a parallelogram are congruent. This is also 72 degrees. So I figured out all my angles. So measure of angle 1 and measure of angle 4 is going to be, yeah, so ugly, 72 degrees. So hard to rate with this tool. All right, and then measure of angle 2 and the measure of angle 3 are going to be 54 degrees. All right, let's go on to number 13. In this rectangle, they gave us some lengths. Find the value of x. First off, please draw the rectangle so you can see what you're looking at. Okay, now where you label, it doesn't matter. Start somewhere. If I go H, I, you need to go in order H, I, J, K. Okay, then it gives me HJ. So now I know what I'm looking at is the diagonal. They say this is 3x plus 5. And then they give me this diagonal IK, and they said that is 5x minus 9. Now I need to know this property. I'm solving for x, and I know in a rectangle, diagonals are actually congruent. That doesn't happen in a parallelogram because you're slanted. But in a rectangle, your diagonals are actually congruent and they bisect each other. Well, just set the two diagonals equal to each other. You're just going to do one of these. 3x plus 5, that looks like a 4, but it's a plus, equals 5x, I have to slow down for it to catch up, minus 9. And then solve this. Minus 3x to both sides, minus 3x. It doesn't like it if I go fast. 5 is going to equal to 2x minus 9. And that was an equal to sign. Okay. Add 9 to both sides. And this is so slow, and I apologize. 9, I'm going to get 14 on this side equals 2x. And the last thing, and I'm running out of space, is to divide by 2. So I'm going to bring it over here. X is going to be equal to 14 divided by 2, which is 7. And I'm finished. All right, on to the next one. All right, so for 14, for what value of x is the quadrilateral a rhombus? Well, you need to know properties of rhombuses. You know they have 4 sides congruent. You also know in a rhombus, and you can look at some of the properties. In section 5.5, you have properties of rhombuses. And I moved away from my computer, so you probably can't hear me. All right, so one of the properties is the diagonals of a parallelogram are perpendicular, then the parallelogram is a rhombus. Also, this property, 54, is the one we're going to use here. Theorem 54. Okay. This one says if one diagonal of a parallelogram bisects a pair of opposite angles, then the parallelogram is a rhombus. So what would make this a rhombus is if this diagonal bisected a pair of opposite angles. So meaning this would be congruent to this. So to make that work, you just go 6x plus 32. This is just your basic math, equals 17x. That's supposed to be a 17 minus 1. Go ahead and do the algebra on this. Subtract 6x, move this to this side, and work that. I'm not going to work that for you. That's just basic algebra. You should come up with x equals to 3 here. Just knowing that property, the theorem 54, is how you set this up. Is you want these to be congruent so that this diagonal bisects the pair of angles. All right, let's go to 15. Find the measure of each angle in the isosceles trapezoid. Okay, well, let's think about the isosceles trapezoid. In isosceles trapezoids, base angles are congruent, which would mean this is congruent to this. So measure of angle 3, done. Measure of angle 3 is 55. Okay, so I know that right away. Good. Now I also, if I flip this trapezoid on its other side, these would be the base angles. So I know those are congruent. Well, I know based on my formula, n minus 2 times 180, that I should have my interior angle sum up to be 360. okay, of a trapezoid, they should sum to be 360. If this is 55 and this is 55, well, 55 plus 55 is 110. So I'm going to subtract that off. If I subtract off these two base angles, I'm going to get 250 left. Well, that's what I have left for these two angles. Since they're congruent, because this is an isosceles trapezoid, I just take 250 and I divide it by 2. Well, 250 divided by 2 equals 125. So I know this is 125, and I know this is 125. And my annotation guy is not working so hot anymore. It was happy at first. Okay, let's go ahead and go. All right, for number 16, you need to know the trapezoid mid-segment theorem. I believe it's page 308 or maybe 309 in your book. It's theorem 58, the trapezoid mid-segment theorem. You know this is a mid-segment because this is congruent to this and this is congruent to this. It connects the two midpoints of the sides. And the mid-segment theorem just basically says this. Just know it. The length of the mid-segment is, this length, is half the sum of these two. So to find this length, you just find the average of the big and the little. So 16 plus 8 and divide by 2. The math is super easy here. It's just asking you if you know your theorems. Add those together, divide by 2, you're going to get 12. All right. Let's go to this one. Find the measure of the numbered angles in this kite. So work through this. Let's see what we know. In a kite, we know this side is congruent to this side. This side's congruent to this side. We also know the diagonals here are perpendicular. So right away, I know angle 1 already because diagonals are perpendicular. The measure of angle 1 is going to be 90 degrees. Bam. Good. If that's 90, this is also 90. Sweet. If this is 90 and that's 51, I can figure out angle 3. I just go 180 for this little triangle here, and I subtract off 90, which is going to give me 90 left. And then I subtract off 51. Let's see, and I'm going to get 90 minus 51, which is 40, 39. So I'm going to get measure of angle 3 is 39, and it makes me write slow, otherwise it does that. Yeah, measure of angle 3 is 39. All right, now we got to figure out angle 2. Well, angle 2 is easy. Look at this as a big fat triangle right here. In this big fat triangle, we know this is equal to this. So you have an isosceles triangle. And if you have an isosceles triangle, base angles are congruent. If that's 51, that's also 51. Measure of angle 2 is 51. And just knowing your theorems and postulates makes these really easy. Okay, on to 18. Okay, this should be pretty basic. What are the coordinates of the vertices of a rectangle with base length B? So this base length is going to be B. And the height H. Just find the coordinates in terms of B and H. So C right here is going to be 0, 0. Because it's at the origin. Done. Now let's find this coordinate. I go over 0 on the x-axis, but I go up the height. So this point, B, is going to be over 0, and then the y, I go up h. Since the height is h, that's how high I go up, 0h. All right, now let's find point D. I know the length is B, so I'm going to go this way in the negative direction B. So this point is going to be negative B, comma, I go up nothing, up 0. And then this point here, I go back this length B from 0, I'm going in the negative direction, that length B, and then I go up h. So this will be negative B, comma, h, and I'm finished. All right, so that's just making sure you can label coordinates in terms of variables, not numbers. All right, for this parallelogram, find coordinates D without using any new variables. Now in a parallelogram, you know diagonals bisect each other. So that means this length would have to be equal to this length here. So if I go up 2a. This is the point over 0 up 2a. If this length is the same, I would have to go down 2a. So this point for the coordinates would be over 0 on the x-axis. I don't move anywhere on the x-axis. I go down 2a, negative 2a. And there's my coordinates for D. That's a 0. Okay, let's look at 20. For the parallelogram, find the coordinates for D without using any new variables. This one's a little trickier. I want to find the coordinates here. Now I can see I go over all the way to here, and then I go up to here. So I'm not sure how to get all the way. What is that on the x? I can't use new variables. I have the variable a, I have the variable b and c. So I go over this far. I'm not sure how far this is, but I do go up the same height as here. So the height here is c, so the height here will also be c. There's my y coordinate. Now I have to figure out my x coordinate. Here's my x coordinate. How far do I go over? Well, let's think about this. This length here is a, because I go from the 0, 0 over a. This length here also has to be a because this is a parallelogram. Opposite sides are congruent. If this length here is a, and from here to here, I go over b, this I'm just going to add over on this side. That's how much more from here to here is how much more I went from here to here. So if I straighten this out, I would go all the way over to here. I could see this length. Right here is A, and that's the little section left over. That little section is B. I go over B here, and then I add this length A. So this point all the way to here is going to be A plus B. So here I'll have A plus B. That's my x part. And then my y part is C. Let me write it better. A plus B will be my x coordinate. Yeah, that's a B, comma, and then my height will be C. So I go over this B part plus the A part. That's how far I go over on the x-axis, and I go up C. All right, let's go on to 21. What type of quadrilaterals have all angles congruent? So let's name them. Quadrilaterals, 4 sides. So I know a parallelogram. Nope, not all angles congruent. The ones I do know for sure, a square does, yes. A rectangle, yes. A rhombus, no. A kite, no. A trapezoid, no. So what type of quadrilaterals? I would say a rectangle, because we know they have 4 right angles. Yeah. Okay, that says rectangle, and I can't make it. It's getting worse as time's going on. Let's try this. A rectangle and a square. And you're done. All right, and it went away. That says rectangle and square. I think we got it. All right, let's go ahead. Number 22 asks us to give the name that best describes this figure and then find the measure of the numbered angles. So let's look at this figure. I have both sets of opposite sides parallel. So I have a parallelogram first off, for sure. Now my diagonals meet at right angles. And when that happens, it changes my parallelogram more specifically to a rhombus. So now that I know this is a rhombus, I have to write it so slow or it won't look good. Okay, now that I know it's a rhombus, I can use the properties of a rhombus. Diagonal bisects angles in a rhombus. So if I have the measure of 52 here, I know this is also 52. Now, since it's a parallelogram, these are alternate interiors, so this is also 52. So the measure of angle 1 and the measure of angle 2 is going to be 52. Everything is 52. And that is a 2. My neighbor's car alarm is going off. That's a 2. Okay, measure of angle 1 equals the measure of angle 2 equals 52. All right, let's go to 23. A man is making a square frame. How can he check to make sure the frame is a square using only a tape measure? So basically, he can only measure lengths. He can't really measure angles if he's just using a tape measure. So if he's making a square frame, first of all, if you want it to be square, you want all the sides to be the same. So the first thing I would do in a square is I would check to make sure all the sides are the same. So that's write that out. Here comes my text box maybe. Okay, so I would first, no, text box. The length of each side. Then after that, I would, all right, the length of each side is the same. Well, it could be a rhombus. You could have it slanty. How do you know that you're going to get a square? Well, in a square, you want the diagonals to be the same length, because if it's slanted, your diagonals won't be the same length. So first check to see the sides are the same length. Then check to see that the diagonals are the same length. All right, and that's how we're going to do it. And my box went away. All right, let's look at 24. Is the quadrilateral a parallelogram? Explain. The diagram's not to scale. How do I know if it's a parallelogram? Well, going back to those properties of parallelograms that we talked about, I want you to explain to me how you know it's a parallelogram. Let's look. One of the ways we can know a diagonal is a quadrilateral is a parallelogram is if both sets of opposite sides are parallel. Well, look what I have here. Let me get a freehand. I have this side and this side. Are these sides parallel? Well, here's a transversal, and these are marked as congruent. So alternate interior angles are congruent. This is parallel to this. Yes. Now let's do the other side. Well, let's look. This side and this side has a transversal, and its alternate interiors are congruent. So yes, this is parallel to this. So here's what I want you to say. Is it a parallelogram? Yes. Here's the reason. And I'm going to type it again because this thing doesn't let me write very well. The reason would be this. You would say, and I lost my text box. You would say alternate interior, okay, I'm just going to speech it. Alternate interiors are congruent. Okay, maybe it'll let me type now. Yes. Both sets of sides are parallel because alternate interiors angles are congruent. And that's what you say, something to that effect, all right? The last one, okay, make sure you explain on this one. On the test also, this will have a text box for you to explain. If you don't explain, you're not going to get full credit if you just say yes, okay? You need to give me an explanation that's accurate. All right, number 25. All sides of a quadrilateral are congruent. Is the quadrilateral a parallelogram? Explain. So if I know all the sides are congruent, let's just say I have a quadrilateral like this. This is congruent to this, and this, and this. All the sides are congruent. Do you have a parallelogram? Yes. That's one of the rules we talked about. It was one of the rules one of the theorems back on the page when you classify parallelogram. If both sets of opposite sides are congruent, you have a parallelogram. So I would say yes, and this is why. If both pairs of opposite sides are congruent, then the quadrilateral is a parallelogram. So just state that theorem. More specifically, if they're all congruent, you have a rhombus. And if you can get the angles congruent, you can have a square. But you just need to answer that question and you're finished. All right, there's the test. I worked through it. Let me know if you have any questions. Have a good day.